Good morning, or I guess maybe you're not watching this in the morning, so it might not be morning for you. But welcome, and we're going to venture on into Section 5. And Section 5 of Chapter 1 is all about subtracting integers. So, first things first, our learning, I'll say put this heading up at the top of your paper, Chapter 1, Section 5, Subtracting Integers. And as we begin every lesson, we talk about what's our goal and what's our target for learning today. And it's going to be pretty straightforward, just like our title. Today, we are going to be able to say, I can subtract integers. And remember, integers are simply all the whole numbers, 0, 1, 2, 3, 4, 5, and so on, and their opposites, -1, -2, -3, -4, -5, and so on. All right, so we've conquered adding. Now, of course, we got to move on into subtracting. All right, I want you to think of what is the highest place on Earth? What do you think it is? Pause and take a guess. Okay, well, according to my sources, the highest point on Earth is indeed Mount Everest. Mount Everest sits at the highest point, I guess, is about 29,028 feet above sea level. So if we're thinking that, let's see, there are how many feet in a mile? 5,280. So this isn't quite 6 miles, 5.5 miles, maybe somewhere in that range on a clear day when you can get all the way up there. Now, here's a trivia question for you. If the Mount Everest is the highest place or the highest point, do you know where the lowest point is? Stop and think, take a guess. Now, some people, when I've asked this during class before, have guessed places like Death Valley, which definitely has an elevation that is below sea level. New Orleans, parts of that city are below sea level. But actually, the lowest point on Earth actually is in the ocean called the Mariana Trench. I'll move this out of the way. Out here in the South Pacific Sea or South Pacific Ocean. And according to what I looked up, 35,840 feet below sea level. Wow, that's over 6 miles deep. And in fact, if we could somehow take Mount Everest and chop it off or saw it off at its base, turn it upside down, put it in the ocean, not only would that peak, once we get it all the way down to the bottom, not only would it touch there and still be covered by water, but it would still be covered by over a mile of water. Isn't that a crazy thought? Oh my goodness. Now, the point of today is to talk about some positive and negative numbers. And so Mount Everest, because it was above sea level, we think of that as a positive number. The Mariana Trench, because it's below sea level, we think of that as a negative number. And if I asked you, how far is it between these two elevations? In other words, what's the difference? Remember that our terminology when we talked earlier in the chapter about translating between English words or our language and then translating it into math, we said difference is a subtraction word. So really, I'm asking you this question. What's the difference between this giant, big positive number and this negative one? And maybe the best way to illustrate this is if we think of almost like a giant thermometer or like a vertical number line. And so 29,028 is positive. It's way up here somewhere. And then here would be 0. And then this negative 35,840 would be way down here somewhere. And when I'm asking you the difference, I really just want to know what's the distance between here and here. How far is it? And well, we know this chunk of it is 29,028 to 0. And then I know from here to here is really another 35,840. So really, what you're doing here is actually adding these two numbers together. In other words, this subtracting the negative actually turns into adding these two together to end up with your final total. Which, now just for the record, if I was adding this together, let's see if I can get this right. 868, 50, I think it's 64,868 feet total. Holy mackerel. It's like almost 12 miles, 11 some miles. I don't know. That's a huge, huge, huge distance with what we're talking about. But the big thing here is that I want you to understand that this subtracting a negative actually turns into plain old adding. How can that be? Well, I have some news to break for you. It's kind of a secret. And if you have younger brothers and sisters, you can't tell them yet because they really can't handle the truth. I'm kind of pulling a Jamie and Adam moment here. It's a Mythbuster thing. Are you ready? Promise you aren't going to tell now. This is something only you can understand because you now understand integers. Shh, subtraction really doesn't exist. We told you that when you were younger, calling it takeaway and things, but you know what? It really doesn't exist. And here's why. Subtraction is really just addition in disguise. Every single time you say subtraction, now that you can handle integers, subtraction is just adding the opposite. So when you look in your notes now, I'm either going to always say make subtraction adding the opposite, or if this helps, you can think of it this way. Keep, change, and switch. And here's what you're going to do. Keep the very first number in the problem. That one stays the same. Then you're going to change from the subtraction problem and make it an addition problem. And finally, then you have to switch the second number, what's being subtracted, to its opposite. Keep, change, switch. This is where you make it add the opposite. Okay, the change in the switch part. The only way this is going to make sense is if we do a whole bunch of examples. So here we go. -7 minus 4. Keep the first number. Change this to addition and then take the opposite of that number. This is the same as -7 plus -4. Ha ha ha! Now, depending on how you like to visualize this, whether you're thinking number line way, where I go backwards 7 and back 4 more, or if you're thinking of lining up integer chips or what I call like the magic armies, you've got everybody on the negative team. Final answer, -11. All right, let's do another one. 8 minus -5. Keep that first one. Change this to an addition problem, but when you change it to addition, you have to take the opposite of this number, and the opposite is +5. Huh! Well, that's just 13. Let's keep going. -6 minus -3. Keep the first number. Change to addition. Take the opposite of -3, which is +3. Okay, -6 plus 3. The negatives are winning this battle because there's more of them. The difference between the two is 3. This one, keep the first number, change this to addition, switch this to its opposite, +6. This is really 9. Now, I know some of your teachers last year, when you saw this, they might have used a little word phrase maybe to help you realize if you have subtracting a negative. They might have called that a chunky plus sign or chop chop or something like that. So if that makes sense to you and works, just keep using that idea. Couple more. Keep, change to adding, take the opposite of 1 is -1. -4 plus -1, -5. Move on to the next one. -7 keeps the same. Change to the opposite, switch, or I'm sorry, change to adding, and then switch this one to the opposite, which is 8, +8. -7, +8 should end up with +1. All right, you'll practice a bunch like that. You might see some that they start to write algebraic expressions.